Okay, this is going to be a quick update because apparently I've only got 8 minutes left on the SD card. I have managed to extract the original multi-section electrolytic. That took some doing. Getting to this rivet right here was not very easy because it is tucked in. Where's my plastic pointer? There. It is tucked in right... That's really hard to see. Right down in here, roughly. It's not easy. I had to push past a few wires, not damage the jacketing. Managed to pop it loose with a little bit of gentle prying from a screwdriver between the chassis and the base of this phenolic wafer. Eventually it popped out free. I did carefully unsolder most of the wires. Some of them I clipped because there was just not a lot of space. And you might notice I'm working with the dial in place here. I tried to remove the tuning condenser when I was doing the capacitor replacement work on the north end of things here, and discovered that because I can't remove this pulley, I can't actually... Oh, wait a minute. Could I have gone the other way with that? Oh, no, I can't, because they put components across the underside here, so this was basically trapped, and I wound up leaving it in and simply removing the dial string. To get to a few things. I can remove it. I actually have it under increased tension here so that it actually works properly. So we now have a full range of motion on the tuning dial. Got the bearing lubricated and moving nicely, but I had to stretch the spring a little bit further because it had lost some of its tension. It wasn't putting enough squeeze on here to actually get this to work right. Anyway, that is out, and in its place, this is really cool, here is our populated Adapt-A-Cap. I am really excited about these. Really well done little piece of kit. I do need to dig through and make sure I have some number 6 hardware to mount this all up with. Might have to go to the hardware store tomorrow to get that. Now, before I took this thing out of there, one thing I made absolutely certain of, and I've done this before, is to make a drawing of some kind as a reference, because one of the things I discovered that is just a little bit different between the original capacitor and the Adapt-A-Cap is the position of the mounting holes, these two little circles, compared to the position of the 4 terminals. Now, the order that they're in, blank, half moon, square, and triangle, is the same on the Adapt-A-Cap. The only difference is, in reference to the 2 holes on either side, Yes, hello. What? Not right now. The Adapt-A-Cap is actually rotated over, at least from the side that says frame on, and I'm using that as the bottom. This assembly is actually rotated 1 position over counterclockwise compared to the original. So the blank side on this one is here. The blank side on... Wait, did I do that right? Yes. The blank side on this one is now over here. Half moon is here. Square is here. Triangle is here. On the original, we have blank. No, sorry. That's triangle. That's half moon. That's square. This guy's blank, so the whole thing has gone over that way. The blank one, by the way, that is the important one. That is the 10-volt cap for the filament connection. I gotta make sure I don't screw that up. Yeah, so this actually has a 60, a 40, and a 20 at 150 microfarads each, and a 200 at 10 volts. I've got a, let's see, 68 at 160, a 47 at 160, a 22 at 160, and then a 220 microfarad at 16 volts as replacements. All good name brand, Nishikon, Illinois, and Mallory. Those will be going back in. And one thing I also removed is this little guy. This little 0.01 disc capacitor. This is the first line cap. Actually, technically, it's the only line cap in the set. This went between this lug right here for ground, or floating chassis ground, and the connection going directly to the rectifier. This is one of the power connection. So this guy right here, I'm going to try and get the fuse hooked up to that somehow. I haven't figured out how I'm going to get that in here. Might have to go over the top of the chassis with it. And I have removed the selenium to get a little more room in there. So this has to be replaced with a safety cap. Going to go with a Y-type because it's not actually across the line. Or, well, I'll need to double check that. I don't think it is. Yeah, it doesn't look to be. So I will replace that. And yeah, I will get back to you in a moment after I have managed to get this installed and get the connections tied back in. And with that, everything is done. And I'm actually pretty impressed at how fast I was able to move along with this. It probably took me less than an hour to wrap up all the connections in the lower section here. But before we get to that, I might as well take you up north and show you everything that's been done. Starting at the top up by the volume control here. Got new film caps in there. This one here, that's a film. We got one here. This guy here. There are two trapped underneath here. We've got this one you can just barely see, and then there's an additional one, I'm saying like a 0.02 or 0.03, trapped underneath this board right here. What I wound up doing was it's connected to a tube socket just up in here. I undid this end at this pin and clipped off the other end, which is attached to an IF transformer down in here, and just sort of pulled it through with my hemostat. It was slow, but I was able to get it done. This one I actually wound up doing the hook and loop method because it was way too far away from its target, which was a tube socket down in here and underneath the oscillator coil. So that would have been a little too tricky to get to ordinarily, so I just cut the old cap there and spliced it in. And the other end is attached to the last post on this terminal board. That's all new. There is one safety cap, this guy right here, on the upper section. Since this one is going to chassis ground, I made sure this was a Y-type because this is, I can't remember if this is coming off. I believe this one is coming off of the power line. There's two. There's one that goes directly off of the line, and there's one that comes off of B+. This might be the one that comes off of B+. Anyway, swap that out for safety. Then came down, got the old multi-section electrolytic removed. The old one has a 22 kilo-ohm, presumably a half-watt resistor. I did one at least a half a watt. That's about how big it is. That went between the, what is this? The half moon and the square sections. And that's also double checking to my drawing. It's this guy here that goes across those two terminals. I know I'm got wonderful art talent here. But that really came in handy when I had to go in there to do everything to get this set up. It's pretty hard to see. I'll see if I can get you in a little bit closer. As I mentioned earlier, because of the slight change in orientation of the four capacitors on the Adapt-A-Cap being one position rotated over counterclockwise, I had to make sure I had all the connections. Is that focusing in down there at all? I think it is. It's hard to see. Basically everything wound up being one place over. So the wires were long enough to reach everywhere, mercifully. I put in a new 22 here, and I also put in this guy, which is a brand new 680 kilo, sorry, this is just a 680 ohm. So, let me, for the sake of my own amusement, and to make sure I didn't screw this up, let's just verify that what I have in here is a 22 kilo ohm. Well, of course, now that everything is in here and it's all bypassed around, I'm pretty sure I did pull that out of the 22K bin. Pull out another and look at it. Yeah, that's a 22K. always make sure to double check, because sometimes I'm pulling multiple resistors out, and I don't remember if I pulled 22 kiloohms or 20, you get the idea. Anyway, 680 right here. This one was actually out of tolerance. It goes back to the power switch and all the way over to the half moon, which is up here now instead of over here. And just all the other wires, there were 2 chassis ground connections. The chassis grounds on the Adapt-A-Cap are at the, there's 4 of them. One on that edge, one on this edge, one down here, and then one over on the right. I utilized that one and that one. Just barely had enough wire to make that work too. And by the way, I did all of this with the dial cord in place. I was very careful getting these connections in here. It was slow and tedious, but it all worked out really well, actually. So that's about it for the Adapt-A-Cap business. The one last thing I wanted to do was figure out how to install the fuse holder. I didn't have the chassis mount style or even the screw-in type. I don't normally keep those around. But I did buy a few of the automotive style inline fuse holders because in larger chassis they tuck under nicely and the wire was about the right gauge and everything. What I realized was in the space that the selenium rectifier originally occupied, it had ventilation holes right here. And those ventilation holes are larger than the wire used by the fuse, and the ventilation is off to the side of the cord reel. So what I was able to do is use 2 of those holes as pass-throughs for the fuse holder out here. And since the chassis hangs upside down, the fuse holder will be well and clear out of the way of everything. There's plenty of room inside there. It doesn't interfere with the cord reel. And I was able to reuse the mounting point for the selenium for this 2-post terminal board. It's bolted in the center. The lower one became the new connection for the rectifier diode and our other Y-type safety cap. This is a 0.01 right here that goes to the chassis ground on the Adapt-A-Cap, or the floating ground, I'm sorry. This is chassis ground. This is our floating negative. So, this side right here is our incoming power from the cord reel going into our fuse. Fuse comes back into the lower terminal, goes to the rectifier diode, and then on to everything else. So that all worked out great. Now, the one major mechanical problem I was having with this thing was the dial cord slipping. And I played around with it, and what I discovered, or at least what I'm assuming was the original problem, came down to the coil spring on the actual dial here. That and really dried and cruddy grease in the one... This tuning condenser only has one actual bearing at the head of the shaft here, and then all the other ones are just sort of a bushing inside the frame of the condenser, and it's got conductive wipers for the center. They're made out of brass. So I made sure to get a little bit of cleaner and lubricant in each one of those. Worked it around a decent amount. And if I jam a knob onto this guy, I also got all the old dried nasty grease off of the control assembly down here, cleaned that up, made sure it spun. But what I wound up having to do was stretch the spring a little longer. I'm pretty sure this spring has weakened over time, and so it wasn't pulling on the cord just enough to get it to go all the way through. So that's one end of rotation, and still no slipping, and right there we're at the other end of rotation. Perfect. The original mounting point is this little punch out right here, and there were a few other holes in it. I'm not entirely sure what those were for, maybe factory marks. I didn't have any stiff springs that were shorter than this that could have provided more pull, so I cheated and I drilled a hole just slightly further down from this for this to hook into, and that provided enough tension to get this spinning reliably. The one side effect this had, though, the tuning condenser is mounted to the chassis via this bracket mounted on the side here. And it's just got these 2 self-tapping screws on it, and then the tuning condenser itself is held in place with these 3 quarter-inch head self-tapping screws through 3 insulating points, or rubber bushings there, which are actually still pretty pliable, so I'm leaving those alone. Those electrically insulate the condenser's body from chassis ground, so it's floating. There's actually a separate wire on top that it connects to. In fact, I believe it's this black one right here, this coated one that goes over to the oscillator coil. That one attaches into the lower part of it, and it's that acts as its ground. What happened was, when I increased the tension here, this whole assembly pulled slightly towards the knob, just a little bit. Doesn't have a lot of motion that it can go through, and the opening in the chassis that this fits through has very little room on the other side. So when I pulled it towards it, the body of the condenser that pokes through the chassis actually rested against the chassis, and that gave it continuity between the two. So to counteract that, the selenium rectifier had a thick cardstock sheet as a, it was more of a heat dissipation thing, or a just to keep the 120 volt line away from the chassis. Either way, that was just the right size and stiffness, and I worked it in between the chassis and tuning condenser here to keep them electrically isolated, and I checked it with a meter. We have well over 20 mega ohms of, it just goes off the chart, so we're good there. And at this point, all I really need to do is rig the antenna and speaker back up to it, and we can do a power up and see if this thing still works. What do you want to bet? Alright, here we go. Turn that on. I've got my meter hooked up to the filament connections on the 1U4, just to keep an eye on the filament voltage since it's based on B+. Thank you to a viewer for mentioning that. We are going to just gently bring it up. Now, of course, I don't know which... Traffic's a little noisy. I'm not quite sure where the polarity of things is. I've just sort of got my leads hooked up a little arbitrarily, so we've got about 1/8 of a volt. That's a little concerning. We're looking at about 1.5 volts DC on that. I'll have to check and see about what we should be seeing. I'm hearing static. We're at about 100 volts-ish input. Oop. Dirty tube socket. There we go.
We know that with homelessness comes crime. But and game number 4 Friday night in Miami on ABC TV and ESPN radio coverage on ESPN Radio at 7:30 p.m. Eastern. ESPN's Adam Schefter reporting today. Vikings set to release running back Dalvin Cook. Vikings work. Not a wealthy person, but I'd like to leave a little something to my kids. Now, they're started a memorial service and a black woman celebrating the life of her boyfriend.
Hey, Carmelo Anthony is a person and a player, and
To this issue, discussions, he plans to come up with legislation here, and I love Navage. I told you about.
Yeah, gross.
por el momento, solo había un inconveniente.
Oh, Harlan Gill at 253-2890. Give him a dollar.
Handle.
Fan club.
And she still feels safe.
The Wisconsin White College.
Cancer in their lifetime.
In a golden infant, Simmons presented by Progressive Insurance. play ESPN radio.
I'd say that's pretty successful. I'm still going to take a look at the voltage on this, because that does not feel right to me. Yeah, it just doesn't. Okay, well, maybe I'm a little cautious. According to GE's spec for that tube, it has a nominal voltage of 1.4. Now, I'm only at 100 right now. Gently. So that's 110. That's about 120. That's almost double normal voltage. Not sure I care for that, so I'm going to shut that off. And, yeah, not quite sure about that. I'm going to do a little more research. I may have to increase the size of the power resistor going to the CAN dome from the rectifier in there to bring everything down a little more. So, yeah, I'll be back. Can't quite remember exactly where I left off. I believe I was looking at the chassis and trying to make a decision regarding the filament supply. So the set had a silicon diode and a power resistor in there coming off of the line cord, and that provides B+ and also the A voltage for the tubes. I had to do a double check on the voltage required by those tubes. The GE specs for them seemed to call out about 1.4 volts. So I looked on them, fired everything back up on the isolation transformer, and at line voltage, or about thereabouts, I was getting more around 1.7. And that was just a bit too high for my taste. So I went in, took a look at the resistor size that was in there. I think it was about 126 ohms. I dug around in my selection, and I found I had some ceramic 5-watt power resistors, and I found a 220 ohm, and that brought the filament voltage on the tubes down to about 1.5 volts. So barely 10% over, or a tenth of a volt above. And I tested that actually directly out of my outlet. I discovered that my isolation transformer was actually increasing the line voltage to the set a little bit. And the Variac certainly wasn't helping. I checked with my Heathkit line voltage monitor and compared the two, and there was a pretty good difference of damn near 10 volts. So operating it direct off of the wall was more accurate, and it's at a happy spot as far as I'm concerned. That being said, what I focused on the past few days, though, was the cabinet. Because honestly, that was the part that I was actually most worried about. I cleaned it up to the best of my ability. I have the Novus plastic polish kit. So that, and this stuff here. I used the heavy at first, but realized that most of what was on the cabinet was dealt with by the fine scratch remover A-OK. This thing is staticky, and it's picking up every little bit of dust and crud, and trying to keep it off there is a pain. There was a lot of tobacco residue on this. A lot of green filth came off the paper towels, getting it clean, but I was able to get everything, as much as I could, off of the knobs and off of the dial. Got that cleaned up. So that all looks a lot better. I got the crack in it repaired. Now, I don't know if you can see it. I'll bring it up here. I've got I'm testing out a new lighting setup to try and illuminate the fronts of things at the moment. But we can see, and there's not really much I can do about... There's a bit of hazing on here. I have to give this a good wipe down. This crack right here. Unfortunately, it stands out thanks to my polishing efforts, but it is flush, and it is backed up on the inside with 2-part epoxy. That stuff is not going to come apart. So I didn't want to get any of that actually in the crack because the two-part epoxy is extremely difficult to remove from something once it's bonded to it. And if any of that seeped out of there, I would never have gotten it off without damaging the surface out and around here. And the front of the radio is the best looking part of the set anyway. The back is another story. Got the knobs, both knobs removed and cleaned up, and honestly the plastics shine on there outside of all the dust that's on it. My God. There's some permanent damage on there, and I set the knobs up so when it's off and it's at the lower end of the band, these are vertical, and it really matters much. So that all looks good. The issue that I had with this set is back here. So on the wave magnet antenna and on the handle up here, I thought there was just some sort of a discoloration. There's also some damage up here and over here and on that. And this, whatever this is actually physical damage to the plastic surface. I gently picked at it with a razor blade to see if it was something that was really stuck to it. No. Judging by the other spots on here, either something really hot or something that didn't agree with it chemically, I don't know, maybe adhesive or something, or paint, God knows what, wound up on it and ate into the plastic's topmost surface. And I can't polish it. Nothing I have affects it in the slightest. Some areas cleaned up, like these areas up here went away. These spots right here, I couldn't do anything. I had no effect trying to get that clean. Thankfully, though, it's on the back, so it's not as noticeable, but the handle does bug me. But again, there's just nothing I can do. I mean, polishing it does not make a difference. Oh, one thing I discovered while reassembling it, I had a fun time with this cord assembly here and all that. What I did not realize, this ring right here is actually a separate piece. You can pinch it, and it'll remove from the cabinet so that you can get this out. So that was handy. This pressed back on, the dial pressed back on rather nicely. And all of that works just fine, no binding. And I suppose the only thing to do now is to actually try it out now that the whole thing is reassembled. So let's grab that out of the back. And I swapped out my temporary fuse that I had it in there for a more appropriate one. So, only downside is I may have to turn off this fluorescent here. So that's probably going to offer some interference. There's a lot of electronics down here to mess with it. This should not take too long. And there it goes. But I'm also at the end of the band here.
A craftsman working in harmony.
This thing can also get exceptionally loud for such a small set.
It is in hugely deep debt. Why does he think he's presidential material?
Exactly right. Wait, you can call us and get started in physical therapy without a
And if people are worried about their time, you'll come to them.
That's right. Our on-demand services.
That's weird. Where's Como? This is turning out to be a lot less impressive than it was earlier. I was getting quite a few more stations yesterday.
Almost.
Oh, it's right there.
Presented by Xfinity.
The Mariners taking out their frustration on the Yankees tonight. 2 games, 2 tough losses earlier this week, but the M's showing the baseball world what they really are capable of on any given night. They find a way to avoid the sweep in New York. It all starts in the first inning. Hey, Eugenio's.
kind of like the height of what it meant to be a successful middle-class American dream type thing, and you had all the innovation, all kind of stuff.
And no awkward face-to-face conversation. In Tri Radio, he is Eric Curley, and I'm Gary McNamara.
Yeah, not a lot locally, but what can you do? But yeah, that's about all there is to it. So all in all, I don't know how much this set will actually get used. It'll probably just wind up on a shelf as decoration. But in the event someone does actually try to plug it in, they will not be disappointed. And it won't also turn into a pile of molten slag. So there's that. But, yeah, I just figured I'd help this person out with these and give me a little bit of experience dealing with sets like this. And what I have learned is that I do not really need to have any of these in my own collection. Whereas I am much more happy working on sets from the 20s and 30s that have gargantuan chassis with ridiculous amounts of space to mount capacitors in them. And cabinets where I can actually repair damage. I can do things with wood. Plastic, yeah, I don't know. That's the sort of thing where I would sand it and have to repaint it for it to really look good. But the rest of this cabinet is actually really nice, so it is what it is. Either way, that's going to do it for now. I am going to need to get these back to the owner on the weekend, and I hope the rest of you guys have a great week. Thanks for watching.